In this lecture, we will be discussing about acid-base titration. Now, if I ask, what is acid? Acid is a substance that provides H plus ion into the solution, that increases H plus ion into solution. So this is a simple definition of acid. And what is base? So if I say it increases OH minus ion into the solution. Like HCl is a strong acid, NaOH is a strong base. H2SO4 it will give you H plus, so this is an acid. Calcium hydroxide, this is a base because it will increase OH minus, that will increase H plus, this will increase H plus, this will increase OH minus. Now let us discuss about acid base reaction. So if I have HCl and it react with NaOH, this will give you NaCl plus H2O. So this is a acid base reaction. So this is acid and here you have a base and then you have salt plus water. So this is a acid base reaction you have. Acid base reaction is also called neutralization reaction. So acid base reaction, because each has a property to neutralize each other. So acid base reaction is also called neutralization reaction. Now let us say we discuss three kind of equation. First is molecular equation. And what is molecular equation? In case of molecular equation, a species are or molecules are shown undissociated. So molecules are shown undissociated. Let us say the above equation is a molecular equation. So NaOH plus HCl, and this gives you NaCl plus H2O. So this is the example of molecular equation. Now another kind of equation we define, that is called total ionic equation. Now in this kind of equation, what we do, molecules are shown dissociated. So if I have ionic molecules are shown dissociated, while covalent and solid substances are written undissociated. So let us say the above case, NaCl and NaOH, these are ionic compounds, will write Na plus dissociate OH minus, HCl will write H plus plus Cl minus, and NaCl we can write Na plus plus Cl minus, and H2O will be written as simply H2O because this is a covalent molecule. Now we define third, that is called net ionic equation. So this is another kind of equation, net ionic equation. So what is this? In this case, we only show the ions that actually participates in reaction. So only actually participating in reaction ions in reaction is shown. Like if you see the above reaction, I have Cl minus this side, Na plus this side, Na plus this side, so we can cancel. So finally net ionic equation I have H plus plus OH minus, this gives you H2O. This kind of ion that simply cancels are also called a spectator ion. So in the above case, a spectator ions are Na plus and Cl minus. Now what is a spectator ion? So if you see, you have a solution of HCl and you have a solution of NaOH, and this solution is basically H plus plus Cl minus, and this solution contains Na plus plus OH minus. Now if you mix these two solutions, you will have water that will form, and solution will have Na plus ion, and solution will also have Cl minus ion. So initially you have Na plus ion and you have Cl minus. Finally also you have Na plus ion, Cl minus ion. So Na plus and Cl minus is not participating in the reaction, and that's why we call this kind of ion as a spectator ion. So we can say Na plus and Cl minus ions does not participate in neutralization reaction in the above reaction. Another important point we have, if you have any kind of acid base reaction, overall equation or net ionic equation is same. So for any acid base reaction, net ionic equation that is H plus plus OH minus, and this gives you H2O, is always same. Now next we will discuss titration. So what is titration? Titration is a process by which we can calculate the concentration of an unknown solution by using a concentration of a known solution. So titration is a process by which we can calculate concentration of an unknown solution using concentration of a known solution. So let us say I have a solution. Let us say this solution is a solution of HCl, and concentration of this solution is unknown. So concentration is unknown. So for this solution, concentration is unknown. Now we have another solution, let us say NaOH, but in this case concentration is known. So for NaOH, concentration is known. So what we can do, if I use a titration between these two solutions, we can calculate. So if I use titration, we can calculate concentration of HCl. Sometime this solution, concentration of known solution, is also called a standard solution. So we have a standard solution of known concentration is sometime also called a standard solution of known concentration. Solution of known concentration is sometimes also called a standard solution. Okay, we will discuss how we perform the process of titration. So let us say we are discussing process of titration, and we'll discuss one by one. So step 1 by step 2 and step 3. Let us say I have a solution of HCl and that is unknown concentration. So what will be the first step? And this is the step 1, that is take a given amount of HCl into the conical flask. Let us say 20 ml NaOH is taken in a conical flask. Taken in a conical flask. Let us say we show here we have taken a 20 ml solution, 10 to ml NaOH solution, concentration is not known. We can always measure 20 ml by pipette, and this is 20 ml acid solution has been taken into the flask. Basically this is not NaOH, let us say HCl, because we have said HCl of unknown concentration. So we have to take 20 ml HCl solution in a conical flask. Now the step 2 will be add few drops of phenolphthalein as indicator. So step 2 in this case, add few drops of indicator. And in this case phenolphthalein is used as indicator. So phenolphthalein is used as indicator. Now what is phenolphthalein? It shows basically neutral color, no color in acidic medium. So if medium is acidic, it will show no color. But if medium is basic, it will show pink color. It will show pink color. Now what we do in a step 3, we take NaOH solution, a standard NaOH solution, that is concentration of NaOH known, in a burette. Now this is called a burette. So this is a, and then we run this solution, we add this solution slowly into this conical flask. We also record the initial volume reading. So record, add. So in step 3, add NaOH dropwise into conical flask. That is basically a known solution of HCl. Also record the initial reading of the burette. Reading of burette. So initial reading of burette. And then finally, if you keep adding, a time will come, then solution will become pink. And this point is called equivalence point. So step 4, add up to point when the solution becomes pink. Add NaOH till solution becomes pink. And once you know the solution become pink, you basically note down the reading of burette. Then you note down the reading of burette. Note down the final reading of the burette. Now if you subtract these two, final reading minus initial reading, we can calculate volume of NaOH used. So volume of NaOH used in this titration is equals to V final reading minus initial reading. So Vf is the final reading and Vi is the initial reading of the burette. So let us say now we know what are the things that is given. Molality of HCl, this is unknown. And volume of HCl in this case, that is 20 ml. So volume of HCl, this is known. Now we also know molarity of NaOH. This is known. And the volume of NaOH that is used in titration is also known. So we can say, if you see the mole this reaction H plus plus OH minus, mole of H plus is equals to mole of OH minus. So at neutralization point or equivalence point, we can say at equivalence point equivalence point, valence point, mole of OH plus, OH minus is equals to mole H plus. Now mole H plus, that is mole of HCl, that is M into V. So M, so this is MnOH, OH minus is MnOH into VnOH, and this is equals to mole of H plus, that is MHCl into VHCl. So from here we can calculate MHCl, this is unknown, and this is equals to MnOH divided by VHCl multiplied by VnOH. So molality of unknown solution can be calculated using titration, acid base titration.